Hello everyone, welcome to the Aqua Sense demonstration. Aqua Sense is an IoT solution which we developed to monitor the condition of aquarium so that we can ensure that the required essential attributes such as temperature, correct amount of light, those conditions are met. And this project was developed as a partial requirement of the IoT module. Quickly go through our architecture diagram so you could get a kind of a basic idea how this works. So we have M3 node which has a temperature sensor and ambient sensor which is fixed to the aquarium, but not in this case. We assume that it will be connected in the production to aquarium, which monitors the data, which sends to the M3 node, and via a border router it will be sent to our A8 node which runs on RSMB, which is a really small message broker. And it runs on Mosquito. We will talk about those, and then using RSMB we are sending it to the AWS IoT thing, which is on EC2 instant and which runs on Node.js with the influx time series DB, so we're storing the data and we are dashboarding the information in Grafana. So this is the overall architecture. At the moment we are building the M3 node which has a sensor, and then the border router, and then the A8 host. So we'll start with the border router and then to the sensor and then to the A8. So let's follow up and then see how these configurations are happening. And these are the resources that we have used. We have used Riot. So you can get more information by going into the link through the README file. The Riot is a real-time multi-threading operating system that supports a range of devices that are typically found in IoT, and it has so many features like COPE, MQTT, and UWB, IPv6, and we are going to use some of those in this project. You can read more about it in the Riot documentation. Going back, we have used FIT-IoT lab as well. IoT is a very large-scale IoT testbed, which allows you to run the firmware that you built on a remote testbed without actually going through the trouble of creating the hardware yourself. So that is the FIT-IoT lab, and we have used MQTT, which is a message broker for us to get the sensor data to the required destination that we need. And also, of course, we have used AWS IoT Think. This is to make sure that we can communicate from the sensors to the cloud. Authors, myself, Iresh, Kavindu, and Nirasha. Let's go through the installation. So you need to have a couple of things before you go and install. First of all, you need to go to FIT-IoT lab and create an account for the testbed access, and then you should be able to SSH into the FIT-IoT lab using a terminal. You can find these instructions on the links here, how to create a FIT-IoT account and also how to SSH into the FIT-IoT host using the terminal. And then you need to clone the Riot OS files to whatever the host that you're using, so that we can use it to build our firmware. And then you need to download our project, which contains the code and everything. So I will start from that as a demonstration. So I'll be using Visual Studio Code for this one. You can see I have already cloned the RIoT with its examples. So the best place to copy our project files would be the examples folder, because in that case you don't need to set the path separately. But if you plan to copy or clone your project into a different location, you might want to set the right base, the current directory right here, to match the hierarchy of your file structure. Keep that in mind. Right. So in the host, you can see I have already SSH into the FIT-IoT lab. So I would be going into cd Riot examples. So we'll do a git clone here. So if you let's follow through our documentation. So we want to get the git clone. So this is, I mentioned I have already cloned the RIoT. So this is cloning, that's done. And yeah, let's double check whether we have the project. You can see the Aqua Sense pops right here. Let's follow through again. So then we need to use a couple of boards for this experiment. So we will be using minimum of 3 boards for this one, 2 M3 boards and 1 A8 board. The M3 board, the first one is for a board router, which allows us to communicate via the network using IPv6 address. In fact, let's go. Okay, let me zoom out a bit. Right, we were right here. So we need to have these 3 devices. Let's run the experiment. The command is IoT lab experiment, and you can define what sort of boards that you want. So I need 2 M3 nodes and 1 A8 node. My site is Grenoble, so let me copy this. Right, and you can see the experiment ID has been generated. Let's go into the FIT-IoT and just confirm whether we have our experiment running. Here it is. We have the experiment running, and if you look at it, you can see M300 and 101 has been applied to us, and A8 106 has been given. So these not IDs are very important because we will be flashing onto those. I can see it turned into the running state. Okay, right, so 100, 101, 106. I'm going to use 100 as my board router, 101 as my sensor router, sensor board, and then 106 A8 would be my MQTT Python host. All right, so let's go ahead and start with the next step. So we need to make sure that we have the source set to the RIoT source. So just to make sure that the consoles they have the reference. All right, now I'm going to use 3 consoles, one for board router, which the one that I'm using, and then one for the sensor node, and then one for the A8 host. All right, now let's make the board router. For this board router, we can use the generic board router example, which comes with the RIoT, which is inside generic board router right here. So let's make that. So usually you need to have a firmware file which has extension of .elf, and we can flash it. So let's quickly make that. Okay, and okay, so we need to be inside the RIoT folder for this one. So so one thing to remember is the channel. We can set a value between 15 to 26 here, and these baud rate should be this number because that's the number that's fetching the M3 nodes, and we will make it. So this basically makes the firmware file for us. All right, so you can see the generic board router .elf file has been created. So we'll flash that into our device. So the command is IoT node flash. One thing to remember is the ID here. So we need to make sure that we put this into the 100. So this will flash our firmware into the 100 M3 board. Let's give it some time. Okay, now let's run it and see. Before we run, there are a couple of things that we need to understand. One is we need to make sure which IPs and the tabs are currently using in the IoT FIT-IoT lab. So you can see at the moment tab 0, tab 9, tab 1 is being used, and also tab 190. Okay, and then IP is 3106 3120. We will use something else. You can see in the next command we have to give is uhcpd.py files, and then you have to give IP here. So we'll just slightly change that. So I can use 31 any IP which is not being used. I will say 31 10 or 12, and we will turn it up. So we need to make sure that we are inside our folder for this one. So let's go into the device and then enter the code here. So we need to have sudo, then we will say 31 Okay, so if you get this exception, it means it is already been used. The tab 0 is being used, so we'll change it to a different tab here. So I would use tab 5 maybe. All right, so tab 5 is in use. So you can see hello reply received. That means your border router is up and running. So I have given details on this, like if you're getting this message, it's okay. If not, in the note you can see, it prefix this error message, what to do. All right, so first part is done. Let's go to the other one and set up the sensor router. So for this we need to copy our project, right? So we will copy to Riot examples folder, so that's easier. Like I explained earlier, you don't have to change the path. We'll have a git, so we'll give the source to this one as well. So in this terminal we are going to configure our sensor router. So first thing is we need to set the source, and then we can create the firmware. Note that this is inside our AquaSense folder. So, and remember to use the same channel because we use 15, and here also it should be 15. We'll make it. All right, now you can see the aquasense.elf file has been created. Let's move forward. Now we need to flash this as well. Now remember, we were using 100 for border router, and we will use 101 for the sensor router. So flashed it. So all right, that's done. So when we check whether we are getting an IPv6 address to communicate from our border router, so we can go to the shell of this particular node. You can say ncm3, this is the 101, and then the real number. Okay, and we can issue the command if config, and the IP that we assign should be here. You can see 3111 IP has been assigned, so that means the border router is functional, and this one is working as well. Good. So we have completed up to setting up the sensor router. Now we have to configure the A8 MQTT RSMB broker setup. So A8 board is a bit different than the M3 board. A8 boards are capable of running application used in advanced devices such as set-top boxes and smartphones, tablets, and everything. So the Cortex A8 CPU. And RSMB is a really small message broker. It's a server implementation of the MQTT and MQTT secure SN protocols. Any client that uses this protocol properly can use the server for sending and receiving messages. So the main reason for going with RSMB over the main Mosquito code base is that the Mosquito doesn't currently have the support for the MQTT SN protocol. So more details can be found here. So we will log into the A8 shell and then do the configuration inside of the A8 shell. Now up to this point we were doing we are flashing and we didn't do anything inside the shell, but here in the A8 we can do that. So we need to SSH into the A8. It's not 102. It should be, let's see, it's 106. Okay, so for that I'm going to use the other terminal right here. I'm going to shoot the source command as well. I think we have that. Okay, so we'll have the source set, right, and then we need to go into the SSH of 105. Was it? Let me quickly check. 106. And you can see we are inside that A8 106 host. Now we need to clone our project into this one and a couple of other things. So first of all, we need to get the AWS IoT device SDK, which allows us to run Python inside our A8 host. So, and also it allows us to access MQTT and MQTT SN through this. So we will install this SDK. We can clone the repository using git clone. Note that this should be on the root of the A8 board. It's been cloning, and after we should be able to see the folder here it is. So we'll go inside AWS, and you need to install Python setup here. So I will install the Python setup here. So it might take some time. Let's see. All right, so let's install. Let me exit to the root, clear the screen as well. All right, now we have our AWS installed and we have the 8 also. Next step is to clone our project into the root. So let's do a git clone again, this time again to the root. Going to be taking some time, we will progress. So we need to have this config file that is known as config.conf file, which is a configuration file. So it should be on the root of your A8 node. Now you can use Vim to create the file by yourself and copy this code. That's also fine. Or else we have already put the sample file inside the AquaSense. You just need to use the cp command and copy it back to the root if you want. Both ways are fine. So we will wait until this is created, done. So you can say vim config .conf file, config.conf. all right, and we will just copy this particular one right here. You can copy it to a text edit and remove a special character. You can copy, paste, and say write and quit. All right, so we have the Vim file. Let me get rid of it. It's up to you. And we'll see whether we are getting an IP address. All right, so we have gotten the IP of this one, which we will need in the future because we are going to use this IP for running the configurations. All right, now that's done. Let's go ahead and start the MQTT broker with our configuration. So you can use broker MQTT as config.conf file. Okay, so our broker has been started. Now we have our border router running, just to remind, and then we have our sensor and we have our A8 host running. So let's go back to the sensor, and so we right here now that our MQTT broker is working. We can use it to communicate with AWS IoT things. However, for this we need to have the certificate obtained from the AWS IoT thing configuration. Now from this point onwards, you need to follow the AWS configuration on how to get those certificates and how to set it up. So we have a separate video for that, and after this you can watch that part. But remember, you can stop the video from here. Before going to the step 8, you have to get the certificates. Once you get the certificates, we can continue from the step 8. Now we advise that when you get the certificate files, the PEM files and everything, you will get to know that information. It's always better to upload into a private repository like this. So you have your Amazon root and your keys and readme file. So keep it on a private repo so you can clone it inside your AquaSense folder, so that you should be able to communicate. So I will do that now. It should be in a cert folder. So the if I go here to my host, which is this one, and I will stop the broker. And now we need to have a git clone. Let me copy my private repo and make sure you upload your certificates into private repo so you can clone this easily. Otherwise, it's difficult for you to get it into the A8 host. Yeah, and we need to issue this into our AquaSense folder. Okay, so I'll put a cd and we'll go inside the AquaSense folder, and then we will issue the git clone. Now if you do this, you will see that the cert files are there. Okay, now you are ready to run this. So what you need to do is you need to go to our documentation, AquaSense, and in the final step, after you configure all the networking, we'll do that in the next part, don't worry. You need to make sure you run this Python 3 MQTT snbridge.py file on the host. Now, since we haven't configured the networking part yet, you won't be able to see the output, but we'll just issue it.
For the data management and visualization part, this is the architecture and data flow that we were implemented using AWS cloud services. So as the initial point, the sensor data will be published from sensor into AWS IoT thing, and it will receive to the Node.js service that act as a subscriber in the EC2 instance, and the data will then saved in the influx time series DB using the external persistence data storage with Amazon EBS for persistency, and the Grafana running Grafana service on the EC2 instance will query the data from the influx DB, and it will visualize on its dashboard. So for this architecture, this is let me go through the architecture one by one. So initially we need to create IoT thing, and for that we need to go to the IoT core in the AWS console, and we can go to all devices and things. Here you can see already created two IoT things. Let me create another one. So create a single thing, and we can enter thing name, test thing. Then we can click next, and here we need to get these certificates for the communication authentication. So there is already created policy. I need to create a new one. So the policy name will be IoT thing policy, and here we need to add some rules, some policies here. So for the ease of demonstration, I will add the allow all policy here and create the IoT thing policy. As you can see, we have our new IoT thing policy here. So I can now select it from here to attach it with the thing that we are creating. So create thing. Now it will give this certificate, and it's this is the only time you can download the key file for the certificate. So we need to download this one, this one, this one, and this one for future communication. So after downloading these certificates, then we need to go to the settings tab to get the endpoint. So this is the endpoint that we are going to publish our topics. After getting those two, the certificates and also the endpoint, now we need to add those to the publish site and also this subscriber. After adding those, the MQTT communication will happen, and this is the MQTT test client that we can experience in IoT core. And here I have added the topic that we are publishing from that sensor site, and I can subscribe it. So after subscribing, you can see that data object is already coming to this endpoint, to this topic. And now to store this and visualize this, as you can see here, we are using this EC2 instance. So this is that EC2 instance, and I have already SSH into it. So here we have created this folders, the file. the thing subscriber JS1, we can subscribe to that, subscribe to the created thing with this thing subscriber.js script. Prior to that, we need to, since we are self-managing all our services, we need to install InfluxDB and Grafana. The InfluxDB installation guides here, and also Grafana installation guide. So I've already followed this, and I have installed this and configured. So let me show the status of this. So a second. As you can see, the InfluxDB status is it's running, and also the Grafana server is also running. After configuring these two services, that the InfluxDB service and Grafana, now we need to start the previously shown thing subscriber.js. Actually, I was already running it on background using the PM2 service manager. As you can see, the thing subscriber.js script is already running there. I can show you the logs. As in the thing subscriber, there's a login method to log these when it push to the database, and so this is the login message that when a data packet received, then it will send to the database, and also log into here. Now we can go to the Grafana dashboard. This is the Grafana dashboard, and I'm on this instance IP address, and in the port 3000, and I can go to the dashboards here, InfluxDB, and as you can see, the data is coming, and temperature sensor and ambient line sensor data within 10 seconds time intervals. Here you can see it's updating, lively updating, and I can show you the data source, and it's getting the data from InfluxDB and using this query to get the temperature from sensor data measurement. So this is the end of the demonstration of project 1, and thank you.